Ladies and gentlemen of Algebra 2, we are going to go over this Module 6 Polynomial Functions Module Quiz Modified. And we're going to also cover synthetic division at the end of this test. So let's go work over these. Again, I invite the viewer to go ahead and pause first and work ahead to see if you got it right. Number 1, which statement about the function fx equals x cubed is true? So we have three options here, A, B, and C. One, the function is positive where x is less than 0. And so if we have a, we'll go ahead and graph, see what this looks like. So we got like an xy coordinate plane. And we have the parent cubic function here, fx equals x cubed. So the thing's going to go something like this. So that's pretty well what it is. And so the function is positive where x is less than 0. No, when x is less than 0, we have the function negative. So this is A is not right. The function never increases. Well, the function as we go left to right is always increasing. So this function is answer choice C, which is odd. And the definition for the classic definition for odd function is this: when we have a function is odd where f of negative x equals negative f of x. And then in a calculator we'll see it like this. We go ahead and put in our x cubed. Let me move this over a little bit. There we go. Yeah. Oops. I didn't mean for it to do that. I have to leave it here. Okay, x cubed. So we see the graph like this, and then in the table views where we can really see it, and we see that f of negative, here we have f of 2 is 8, f of negative 2 is negative f of 2. So f of negative 2 is negative f of 2. And then this has what I like to call 180-degree rotational symmetry. If we go ahead and rotate this curve 180 degrees, it'll turn upon itself like that. So anyway, that's that. Next, we have the ice chest shaped like a rectangular prism holds 3,000 cubic inches of crushed ice. The length of the ice chest is 4 inches greater than the width, and the height is 2 inches less than the width, and it gives us an equation, graph the cubic function. So we're going to graph it. They don't give us dimensions other than having a independent w axis and the volume dependent axis. So we're just going to put this in our calculator. V of w equals, I'm going to put this as f of x. If we put in x, or f of w, I'm doing this for the graphing calculator's sake. We have wx times quantity x plus 4 times quantity x minus 2. So we go in here, and in the calculator we have x plus 4, x minus 2. Graph, we just press graph. We just don't see very much at all, but we're trying to get our answer in quadrant 1 here. If you see the graph paper that we're dealt with here, see that we're given this quadrant 1, w is positive, v is positive. So for that in the calculator we can just cordon off to the window. We'll make this 0 here. I don't know about what the x max is going to be. I'll just leave it there for now. Y, I'm going to assume that we're going to have quite a expanse. So I'm going to put 4,000 here, and we're going to go by 100s. And one thing you can do with this is let me do it by 500s. 500s. There we go. So we graph. This is what we get. Okay. Well, we need to get a cubic. We need to get to 3,000 cubic inches. And if we go to the table view, let's see what we have to get up to that. I'm going to go to the table view, control. So at 10, W equals 10 inches, we don't get anywhere. We need to go up to, well, it looks like we need to get up to about 14 inches or something like that, at least. So let's go ahead and change our window. I'm going to go up to 16. If we go up to 16, another thing I'm going to do is I'm going to activate my grid to do this. How do I do that? I go to second, zoom, we have format. We're going to do grid line. Press enter. Now we're going to graph, see what we get. There we have it. And so we're going up by 500, 1,000, 1,500, 2,000, 2,500, 3,000. So right here, and we can do that in the, we can graph by putting 3,000 here for 3,000 cubic inches. So there we have this intersection point, and we could trace, we could look at the, we could go to the graph trace, we see, yeah, so right here about 14 inches, and we can get it more precisely by going back to graph, second, trace, 5 for intersect, and then enter, 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 and so 13.962 inches. So W 13.962 inches. So to the, so about 14 inches, and it really doesn't give us any estimating things. We could use different things. So what it looks like is this. If we go from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, let's go by twos. So we'll go 2, 4, 6, 8, 10, 12, 14. We know 14 is where it's going to happen. And we're coming up here. And so we'll go up to 500, 1,500, 2,000, 2,500, 3,000. So this would be 3,000 right here. And we have a horizontal line here. And going back to the blue one, we're going to intersect right up about here. So things going to look something like this. So something like that is what it's going to look like. Move it over here. Let's do that. So things going to look something like this. So that's going to be our solution. So that's it. Let us move on to problem. Let's see, do we have it? Yeah, about 14 inches. We're going to go ahead and circle that, or underline that as our correct answer. How is the graph of g of x equals quantity x minus 3 cubed related to the graph of x, f of x equals x cubed? Well, what we should know is that in this, if we have a standard, not exactly the standard form, but the kind of the vertex form version of it, we have a, we have x minus h cubed plus k. The h value is what governs the translation left to right. In this case, we have 3. So we have h is equal to 3, which means that we are translating in g of x the original f of x function 3 units to the right. So the graph of g of x is a translation of the graph of f of x right 3 units, and to verify we can go to our graphing calculator. If we go ahead and enter our x cubed function, I'm going to go to a standard window, zoom 6, and so we have that. And so if we go to put in quantity x minus 3, we're going to cube that, and the red one is going to shift 3 units to the right. 1, 2, 3. Okay, next. How's the graph of g of x equals x cubed plus 2 related to the graph of f of x equals x cubed? Well, what we're doing is the graph of g of x, this plus 2 is going to be in that k position. If we go back here and see this, the form here, what in the quadratic function we call it the vertex form, but it's going to tell us the location of the inflection point. So what we're going to do is we're going to, it's the value of the k on the outside, so we are translating up 2 units. So A is our correct answer for number 4. Number 5, how is the graph of g of x equals negative 22x cubed related to the graph of x equals x cubed? Now, one thing that I did in my class is, for problems like this, what I had my students do is to change this to this coefficient inside the parentheses. I had them work it out like this to take this outside the parentheses. So if we cube that 2, we get 8. So that's going to be negative 8, and then we have x cubed. And so what we're doing here is that we are, yes, reflecting about the x-axis, true, but we are also vertically stretching by a factor of 8, but we don't see any of these options here. And so definitely we are not doing choice C. We're not reflecting about the y-axis. And this is not a vertical compression. Okay, what it is, it's really going to be A. And so what you're doing is you're horizontally compressing is similar to vertically stretching. And so we didn't go over this a lot. If you go over by process of elimination, you can eliminate B and C pretty readily. But the form that we're looking for, that they were looking for in the book, whose test this is the form like f of x equals 1 over b, and then we have x, I think it goes like this, x minus h cubed plus k. In this case, if you have b being 1/2, 1 divided by 1/2 is 2, or 1 divided by, let's see, yeah, if you take you divide by 1/2, so that's why you're compressing horizontally by a factor of 1/2, because if b is 1/2, then that is 2, like in the original. So 6, the graph of f of x equals x cubed with 3 reference points is shown below. Which of the following points represents a transformation of reference point to a point on g of x equals negative quantity x minus 1 cubed? And so what we're doing is, if we take this one right here, our h is equal to 1, which means that we are translating this inflection point 1 unit to the right. And so this original reference point becomes 1, 0. These other ones are going to be stretches that are not going to be consistent with that. So, and you can kind of see, I don't know if you can see that very well. What you're going to get is the reference points are going to switch. So the other 2 reference points, this one here is going to shift to the right but down. So there's another reference point. And this one here is going to shift to the right one and go up like this. So these are the three reference points that are transformed, only one of which is given as an answer choice B. Next, 7. Which of the statements about the function f(x) equals negative x to the 12th power is true? Well, the function is not odd, and I think we look back at problem 1, we just know what an odd function looks like. If we graph this thing, it's going to be, we call this an even negative, so things going to go like this and kind of smash up against the x-axis, go like this. So it's like a smashed up against the x-axis parabola. I didn't draw it very well, but so which is true. Well, a polynomial function, the domain of all polynomial functions is exactly this, all real numbers. So that has to be true. The range is not unlimited. That's not true. The function is even, not odd. So B is our correct answer. And then to verify in the calculator, what does the thing look like? In case you had any doubts, negative x to the power of 12. This is what it looks like. See, almost squares off here along the x-axis. Okay, next. 8. Cubic function graph below its general equation. Oh, that's the general equation, is g of x equals a times 20x minus h cubed plus k. Write a specific equation for g of x by identifying the values of the parameters from the reference points shown on the graph. And so we had our original reference points that were going to be here at -1, -1, and then 0, 0, and 1, 1. And so the center one is the easiest one to deal with, because what we're doing is we see that our vertex here, not our vertex, our inflection point is going to be this one right here, 2, 3. And what that is, that's going to be the coordinate pair h, k. So what that's going to be, just kind of working the right here, we're going to have g of x is going to be equal to a times x, and we have h is equal to 2, so we have x minus 2, cube that, plus k, which is 3. So this is going to be it. Now the only question we have left is, what is a? So you can go ahead and substitute in a second point here to see what it is. I'm going to use this bottom one, 1, 2. So 2 is equal to a, and then we have the point 1, 2, so 1 minus 2 cubed plus 3. What is that going to be? Well, what we have is 2 is equal to this 1 minus 2 is -1, and -1 times a is going to be negative a plus 3, and subtract 3, we have negative a, on the left side we have -1 equals negative a. So therefore a is equal to 1. And so what's going to be our final equation for this? We're going to plug 1 in for a. So our final answer for this one is going to be g of x equals, I'm going to put nothing outside because a is 1. Then we have quantity x minus 2 cubed plus 3. So that is what is going to be put here on that blank space here for us as our correct answer. For 9 through 10, use the graph calculator to graph the function, then use the graph to determine the number of turning points and the number and type, global or local, of any maximum or minimum values. So we're going to have x squared times quantity x plus 3. So we go here, x squared, go here. So I'm going to put x squared times quantity x minus 3. Let me make sure here. X plus 3. Okay, it helps to look. So we have this graph. I'm going to put zoom 6, get a standard window. And so we have how many turning points do we have here? 2 of them. And neither of these is a global, because we're starting from greater than negative infinity and going up toward positive infinity, so there are no global extrema. So we're going to say we're going to have 2 local turning points. 2 turning points. I'll call it 2 turning points. And both of these local. Okay, next 10. Same instructions, number of turning points and their type. So we have quantity x plus 1 squared, x minus 1, x plus 2. Oops. Got the wrong one here. There we go. Let me clear it here. So we have x plus 1 squared, quantity x plus 1 squared, and we have x minus 1 times quantity x plus 2. I'm just going to take a quick look back to verify that that's right. I think it is. Yeah, that's it. So go ahead and graph this, and I think we have it zoom 6. So how many turning points do we have here? Well, if we look very carefully, we can see we have 1 turning point here around where x is negative 2, and then 1 here where x is negative 1, down here about where x is kind of close to 1, but between 0 and 1. So 3 turning points, and 2 of these are local, but this one over here on the right is an absolute minimum. It's the absolute lowest value. So what we're going to have is 3 turning points, and one of those turning points, 1 is global, and the other 2 are local. Now, in the fundamental theorem of algebra is that the number of turning points, the maximum number of turning points, is going to be less than the degree of the function. So if we multiply all these x's together, we're going to get x to the 4th power. And so the maximum number of turning points possible is 1 less than the degree of that function. Okay, sketch the graph of fx equals x times quantity x plus 1 times quantity x minus 2. And if we go ahead and multiply all this out, all the x's out, we're going to get x times x times x, which is going to be x cubed. And then it's going to be, we're going to have plus something something, okay? So we can set each of these factors equal to 0. If we set the whole thing equal to 0, x times quantity x plus 1 times quantity x minus 2. And then if we set each of these factors equal to 0, we have x is equal to 0. We have x plus 1 is equal to 0. And solving for x, we have x is equal to negative 1. And finally, we have x minus 2 is equal to 0. And solving for x, x is equal to 2. So we have 3 zeros, one of which is at negative 1. Another of which is at 0, another of which is at 2. And because we have the natured, we have a degree 3, we call this an odd positive nature. So we're going to start from down here and end up here. And each of these has a multiplicity of 1. So we're going to start like this, come up, come down like this, and then like this. Now, if you graph this in a calculator, you're not going to see the dimensions exactly as drawn here, but similar. What I'm looking for is, in the grading of it, is are the x-intercepts right? are the start and the finishing roughly right? When we put this in the calculator, let's kind of get a little critical, see what it looks like. Okay, make sure, remember, here we have x plus 1, x minus 2. x plus 1, x minus 2. Okay. Yeah, it's kind of fairly accurately drawn. We have this minimum, this local minimum is about -2, and this local maximum is less than 1. So let's see what that looks like. Yeah, pretty close, pretty close. Anyway, I'm looking for something like that in the grading. Which graph is sketched below? And so we have, we could graph this in the calculator quite easily, see what it is, but here our zeros are going to be x is equal to -3. We have x is equal to -1. And finally we have x is equal to 2. And if we solve this for our factors, we set this right side equal to 0. If we add 3 to both sides of this first one, we get to the right, we have x plus 3 is equal to 0. So one of the factors in here is going to be x plus 3. Definitely you don't have that in choice B. And then for this next one, x equals -1, we have to add 1. And we add 1, we get x plus 1 is equal to 0. So we're looking for the one with x plus 1, and both of these, choices A and C, have it. Now for this x equals 2, if we subtract 2, we're going to have x minus 2 is equal to 0. So which one has x minus 2? It's going to be this one right here. So C is our correct answer. And you can graph that quite easily in a graphing calculator, see that that is indeed the case. Next, 13. X by x square is cut from each corner of a rectangular sheet of cardboard that is 8 inches wide and 11 inches long. The sides are then folded up to form a box, therefore get the volume equation. So I think when we worked this out, we actually had to find the volume equation from the sketch or description of the box cutaway. So we're going to go ahead and take this 8 minus 2x, 11 minus 2x. So 8 minus 2x. minus 2x. And then we graph, and we don't see very much. I mean, we do see some of it here, but we're really interested in what this is up here, up above here, around where x is equal to 2, right above there. So let's go to the window, and we can start at 0. I think if we go to 10, we can just keep it there. And then for our y minimum, we need to really go up to, go really high. I don't know if it's going to be 300. I don't know what it is going to be, but we can go by, let's do this, we can go by 100s. We'll be okay. Graph. Yeah, so we have more than enough to work with. So we're going to come right, we have our maximum right here, and we can trace. We can just use trace to get there. Do they say according to what? To the nearest tenth. So we can go to the nearest tenth. There are a lot of ways we can do it. One of which is we can go to our table set and put in delta table of 0.1, because that's going to give us the highest when we see that. So if we go to the table view, we can kind of see it's going to be up here somewhere. Yeah, so you look for the highest. You're looking for the biggest number here on the Y2, and the X value that produces that highest value is our answer. So we're still increasing here as we go down. So 60, it looks like 60 is our maximum volume, and that occurs where x is equal to 1.5. So at least we see here. So 1.5, we'll say x is approximately equal to 1.5. Is it in inches? Yeah, inches. And then we can alternatively, we can look at the graph here, and we can go to second, trace, and look for our maximum here, which is 4. Now this is a case in estimating the window where I vastly overshot what the value of y was, because I entered a 300 here, but we only needed it to be 100. So if you overshoot it in the first try, the advantage is I didn't have to go, if I had it way up here, I might have had to reset the window another time. So then it says right bound, press enter twice. So yes, our maximum of, now this is a little bit deceptive, because it says, in the calculator it says maximum, right underneath says x equals 1.525. Well, and to the nearest tenth, that is 1.5 inches. But over here, the actual value of the maximum is 60.0125 inches, or cubic inches. So, but anyway, yes, this indeed is our correct answer. Number 14, write a cubic function intercept form for the given graph whose x-intercepts are integers. Assume the constant factor a is either 1 or 0. And so what we have is, we have x, we just identify our zeros, we have x is equal to -1, and we have x is equal to 2. And our factors based on this, if we add 1, we're going to get x plus 1 is equal to 0. And then if we, for our other one, for our 0 of 2, if we subtract 2, we're going to get x minus 2 is equal to 0. So our function could be f of x equals quantity x plus 1 times quantity x minus 2. And if we graph that in our calculator, we see we're going to do quantity x plus 1, x minus 2, and we graph this. I'm going to go to zoom 6 to get a standard window. So we have our x-intercepts of -1 and 2, and so we look at it. Yes, so we have them -1 and 2, but it doesn't look at, now the right side looks close to it, right? It's coming right here. But on the left side, we should be starting low. Well, what's going to happen is this 0 here, where x equals -1, has to have a multiplicity of 2, because we're just touching the x-axis and bouncing off. So what we have to do is take, I'm going to make this in red just to emphasize, we're going to have quantity x plus 1 squared times quantity x minus 2. So I'm going to go ahead and re-enter this function here, and I'm going to enter it here in the blue. So we're going to have same thing, but we're going to have this quantity x plus 1 squared times quantity x minus 2. And we're going to see side by side how different these are. So we graph. So there it is, the blue one. See, that's the more accurate version here. There it is. So this right here is our correct answer. F of x is equal to quantity x plus 1 squared times quantity x minus 2. So that's it for 1-14. Now the other section is one I added on to this test, where we were studying synthetic and polynomial division. And so for polynomial division, the divisor x minus 3 is dividing the dividend 4x cubed minus 5x plus 2, what would be the proper synthetic division setup. what we have to have is we have to represent, to do this correctly, we're going to have 4x cubed, and we don't have any x squareds represented, so we're going to put plus 0 x squared, and then we have x's. We have minus 5x plus 2, and we're going to divide that by this x minus 3. So what we have to do is we have to put the value of the 0 of the divisor, so 3 is going to have to go on the outside, not negative 3. So based on just this divisor being properly reckoned with, this one right here, answer choice B, is an impossibility. And what happens, our true answer is going to involve having these numbers here, 4, 0, negative 5, and 2, which is going to be answer choice D. So D is our correct answer. Next, 16. If 3x cubed plus 4x squared minus x plus 5 is a dividend and x minus 2 is divisor, what is the remainder of the quotient? Now, we haven't gone into the remainder theorem. In pre-calculus, I think those of you going into my class are going to get into it. But if we have x minus 2 as a divisor, we're going to put 2 out here, and then the coefficients of this cubic polynomial, and they're all in order. So we have 3x cubed, and you have to look at, make sure all the powers of x are represented in order. We have x cubed squared to the first power to the 0 power. So we can just put these numbers of coefficients in like this, 4, negative 1, and 5. And then we can just bring this 3 down here. And what we're looking for, our answer is going to be found right here in the remainders place after all that is done. So 2 times 3 is 6, 4 plus 6 is 10, 2 times 10 is 20, negative 1 plus 20 is 19, and 2 times 19 is 38, 5 plus 38 is 43. So 43 is our remainder. One thing I'm really looking for on this question here is the shown work. So there it is. That is our answer. For dividend of 2x to the fourth power plus 5x cubed minus 8x squared minus 17x minus 6, which divisor will result in a remainder of 0? So we're going to go ahead and do this. I'm just going to do answer choice A, which may or may not be the right answer, but so we have 2. All these powers are represented: fourth, third, second power, first power, 0 power. So we have 2, 5, negative 8, negative 17, and negative 6. And then out here, for answer choice A, we're going to have to put negative 1 on the outside here. So we bring down this 2, and so we have, so 2 goes here. Negative 1 times 2 is negative 2. 5 minus 2, or 5 plus negative 2, is 3. Negative 1 times 3 is negative 3. Negative 8 plus negative 3 is negative 11. Negative 1 times negative 11 is 11. And then negative 17 plus 11 is negative 6. And then negative 1 times negative 6 is 6. So we have a remainder of 0. That's our remainder. So we have found on answer choice A our correct answer. And basically what it tells us also is that quantity x plus 1 is a factor of this quartic polynomial. So that's number 17. Number 18, what is, okay, there's not a multiple choice here, and we see we have 2x to the fourth power plus x cubed minus 6x squared plus 2x minus 6 divided by x minus 1. So we can set up a synthetic division bracket like this, and our coefficients are all present, and all in order. So we have 2x to the fourth, x cubed, negative 6x squared, 2x, and minus 6. And on the outside, we put the value of the 0, so we put x minus 1 equals 0. So x equals 1 is our 0, so 1 is going to go right here. And so we bring down this 2, and when we do that, we're dividing 2x to the fourth power by x. So this right here is going to be our x cubed place. And if we get our first place represented properly, it's going to put everything else in order. So next we have 1 times 2 is 2. 1 plus 2 is 3. That's going to be 3x squared. 1 times 3 is 3. Negative 6 plus 3 is negative 3. And 1 times negative 3 is negative 3. 2 plus negative 3 is negative 1. And finally, 1 times negative 1 is going to be negative 1. And then down here, our remainder value is going to be negative 7. So our answer here is going to be, I'm just going to write down below, we have 2x cubed, then plus 3x squared minus 3x minus 1 minus our remainder over our divisor. And again, I'm looking for the shown work on this, definitely. And so that's going to be it. I hope this has been helpful to you. Good luck, and thanks for viewing.